His works are published in many journals and newspapers of repute. Two of his churches were exhibited at the Fifth Asian Congress of Architects held at Lahore in Pakistan. His work was exhibited at Archifest exhibition organized by Singapore Institute of Architects. Uh, Mr. Bhaga was given Sir M. Vishwesvaraya Award in 1995 by HUDCO for energy efficient housing design. His Baptist Church at Chandigarh is selected by Ministry of Non-Conventional Energy Resources at Terry as one of the best 41 energy efficient buildings in India. He got Michael Ventris Award from Architectural Association London. Police Memorial Jammu, designed by Mr. Baga, was got Outstanding Concrete Structure Award from Indian Concrete Institute. He has co-authored three books, namely Modern Architecture in India, Post-Independent Perspective, New India Homes, and Lee Corbusier and Pere generate footprints on the sands of Indian architecture. He has researched on a traveling exhibition, a dream realized, on life and work of Lee Corbusier and Pere generate for Swiss Arts Council. He worked as co-editor of Conference Proceedings of Urbanism and Green Architecture held at NIT Hamirpur in 2010, Contemporary Architecture Beyond Corbusier in 2011, NICHE 2014, and Rediscovering in 2015. He worked as the chairman of IIA Chandigarh Punjab chapter. He also chaired IIA Publications Board and had been editor of Journal of Indian Institute of Architects. He had been a member of high-powered Finance and Contract Committee of Chandigarh Municipal Corporation and also nominated as councillor there for the term 2012 to 16. He was chairman of Chandigarh Municipal Corporation Committee for Buildings and Roads. Currently, he is a member of Advisory Committee of India's Home Minister on Union Territories. Recently, he has been appointed as head of the Chandigarh chapter of Fire and Security Association of India and chairman of Green and Eco-Friendly Movement JAM Punjab chapter. Sir, I welcome you again in this program and this session. Please take charge of the session. Thank you, sir.
Thank you, Charu ma'am. Thank you so much. First of all, I am grateful to Government Women's Polytechnic College for giving me this opportunity to share my thoughts on climate responsive architecture. Let me start now. I would like to mention that in most of the holy scriptures of India, there's a lot of emphasis on saving the Mother Earth and saving the environment. These are the lines from the holy Puranas, which is a famous Hindu scripture. It highlights, there is a shalok in the Puranas which highlights the importance of a tree in our lives. Likewise, in the Holy Guru Granth Sahib, there are a lot of shlokas, lot of verses which are emphasizing on saving water, saving Mother Earth, saving the environment. And in the Holy Quran also, these are there is a ayat included in the Holy Quran which says Allah has sent down rain from the sky and given life thereby to the earth after its lifelessness. Indeed, in that is a sign for people who listen. So these are the lines from Holy Quran. And Bible also versifies a similar gospel. It says that the God says, I brought you into a fertile land to eat its fruit and rich produce. But you came and defiled my land and made my inheritance detestable. And the point I was making was, in all our holy books, there is a focus on saving the environment. Now coming to the newly coined term, which is called sustainability. Uh, what is sustainability indeed? The simplest definition of sustainability is taking less from the Mother Earth and giving more to people. This chart is indicating the scenario of energy consumption in India. Various surveys are indicating differently, but one of the surveys says that 48% of the world's energy is consumed in the building sector, either in construction or in operation or in maintenance. So, regarding other sectors like agriculture consumes only 5% of the world's energy, transport consumes 12%, industries consume 31%, and so on. And out of the energy consumed in the buildings, 60% of the total energy is consumed by air conditioning alone. And now let's have some look at the historic work done by our forefathers. This is the slide which indicates the Mohenjo-daro township, which was built in 2600 BC. You can see from this picture that the planning of the building is done to suit the local topography, to suit the local materials, to suit the local wind direction and all that. And accordingly, these houses were designed. You can see very modern houses, simpler, there's a jalis and there are no windows and there are narrow entrances and no decoration. And Mohenjo-daro township was the one which was having proper drainage designed system there in place. And the digging done of this township was indicating that there was a proper drainage system well laid there. And during the Mughal period, that was from 1526 onwards, for nearly 200 years, the architecture of India has reached to its full perfection, and the work executed, designed and executed during that period was having all the passive cooling and proper energy efficient features in them, because you can see in this Fatehpur Sikri complex, all the openings are protected with the shajas or projections. Then there are small water bodies to create the microclimate. And in this Mughal buildings, you can see these kind of deep verandas. And in this slide, you can see water running channel, which is going in the Red Fort, Delhi, because in that times there was no electricity. In order to cool the interiors, this water channel was operative. In Jaisalmer in Rajasthan, these Havelis were built. Most of the architects, we have studied this. You can see the typical facade of this building, the Haveli. You can see the self-shading balconies, small openings, local materials, jalis, all those features are there. And you see the kind of architecture produced in Jaisalmer to suit the desert region. You look at the facade of the Haveli, how it was intricately woven and it was self-shading. And they ensured courtyard planning because it was most suited to the Indian kind of climate. How nicely they have decorated the facade, the balconies, And balconies are not only protecting the windows, but they are aesthetic elements in this scheme of things. And they opted for narrow streets because they are self-shading. And in Rajasthan and in Gujarat and in many other parts of India, our forefathers have told us how to conserve rainwater. These kind of rain collection tanks, which are aesthetically very pleasant and functionally exceptionally good. So you can see these kind of step wells in most parts of India. Coming to Rajasthan again, this Hawa Mahal. This was built in 1799, and this was meant. These balconies were meant where royal women can remain in parda, and they can watch the processions and other things which is happening on the street. Yet they can enjoy the cool breeze. And it was a wonderful experiment because at that time there was no electricity. In down south in 17th century, this Jahangir Mahal, at Orsha, this was, you can see in this picture, very thick walls, and then, projections and small openings, all these features were there. During the British Raj, in 1927, when the famous British architect Edwin Lutyens came, he designed this building, the famous Parliament House of India. You can see there's a veranda running around, which is a circulation core, and this was meant to protect this building from the harsh climate. And inside you can see small windows. And the Herbert Baker, a famous British architect, designed the Secretariat building in New Delhi. You can see the small openings. You can see how they are shaded properly. And this was the kind of work done during the British Raj, because the Britishers also understood the climatic conditions of the region, especially Delhi. In 50s, Pandit Nehru, India's first Prime Minister, invited the famous architect Corbusier to design Punjab's capital city, Chandigarh. And when he came here, Corbusier, along with his, three other members of the foreign team, and they were assisted by some young Indian architects too. He advised all of them to first of all study the Indian climate. And the result is, he has taken care to orient the Chandigarh streets, buildings and everything to suit the local climatic conditions. In this, you can see this picture on the left side. This is the open hand monument, which is one of the famous structure in the capital complex of Chandigarh. This revolves like a weathercock. It is the emblem of Chandigarh as well. It gives the wind direction to the Chandigarh residents. Its importance is because it highlights that wind direction is very, very important for the people to know which way the wind is blowing. And Corbusier also created an artificial lake by damming two seasonal rivulets. One seasonal rivulet, rainwater was dammed, and he created this lake. The lake is called Sukhna Lake. And this lake has not only improved the water level of the city, but also improved the vegetation around, and microclimate of the city is also improved considerably because of this lake. Chandigarh is the only city probably in India which has 35% of the green spaces. And I was reading in one of the article in Hindustan Times one day, it says Kolkata got 2% green spaces. Look at the comparison of Kolkata and Chandigarh. And Chandigarh, to my mind, we have nearly 1,700 parks in the city, which is quite a large number. This is the High Court building in the famous capital complex of Chandigarh. In this building, Corbusier introduced a double roof. He also introduced, a combination of horizontal and vertical louvers to protect his High Court building from the harsh climatic conditions. And this is the assembly hall in the same complex. He created these shallow water bodies, to control the climatic conditions. And apart from that, same way he protected all glazing with the combination of louvers. This is the Secretariat complex. Again, the glazing is about 3 to 4 meters deep. You cannot see glazing in this elevation. And there is a terrace garden on the top, and there is this building is oriented in the wind direction. Whenever there's any wind movement, so this building behaves very beautifully. Another small structure, which is called Tower of Shadows, is built in the Chandigarh Capital Complex, which was demonstrative of Corbusier's theories of the sun control, his ideas about sun control. This structure indicates that what kind of louvers are needed on which direction. And the famous campus of Punjab University in Chandigarh, it was designed by a French architect who happened to be Corbusier's cousin. His name was Pierre Jeanneret. This is a very famous building of the Adam building of the university. You can see each floor is jutting out, and each floor is shading the glazing below. In addition to that, there is a small courtyard in the middle. This is Gandhi Bhavan. You can see a huge window which is deeply recessed, and there is a skylight on the top in this building, and the rest of the facade is dead. This is the City Museum in Chandigarh, again designed by Corbusier. Here again he experimented with the idea of double roof. In the middle of 90s, famous architect Charles Courtyard designed this LIC building, and this building, when it was executed, there was a lot of controversy that why he is using so much of glass, in a hot climate. But Korea has used glass very sensibly. He used glass only and only on north side. Then a trend came in India to design these kind of buildings, which are, there's no opening, there's no balcony, there's no shading, and the building is totally clad with either aluminum or with the glass. Look at the kind of architecture we started producing in the middle of 90s. And this is a building in Mohali. A architect of this project is a close friend. He designed a very, very nice building here. But when the building was almost 60% completed, a bureaucrat forced the architect friend to put glass all around. Because he was not agreeing, so that architect was changed at the last minute, and a new architect was placed who agreed to put glass all around. It has the positioning of the glass has nothing to do with the orientation. It is wrapped all around, and building works like a furnace. The same trend is continued in many buildings in Gurgaon. Look at this signature tower, glass all around, and these kind of buildings in Mumbai, glass all around, and in Bangalore, glass all around. The point I am making is, irrespective of whether the building is in North India, South India, Central India, wherever it is, irrespective of the climatic conditions, we have switched over to designing these kind of buildings. which are not suitable to Indian conditions. And what we are supposed to do, coming to that, India is divided climatically into 5 zones, and the zones are uh, Kashmir and parts of Himachal falls in cold and cloudy region, and this golden yellow color, which is occupying most of the portion of India in this map, including Madhya Pradesh, including Punjab, Haryana, and many UP and many other states. This falls in the composite region. Hot and dry region is Rajasthan mainly and parts of Gujarat, and warm and humid region is dark golden color, which is the which are the areas on the periphery of this India's boundary. And moderate region is a small pocket in South India. And first of all, we will discuss the composite region. When we design buildings in a composite region, what we are supposed to do? We are supposed to design buildings which resist heat gain in summer and resist heat loss in winter. How we can do it? We have to orient the buildings, keeping their longer faces towards north and south. We can introduce roof insulation and wall insulation. We can introduce cavity walls or the thicker walls. And we have to promote heat loss in summers or in monsoons. How we can do it? We can introduce courtyards, we can introduce wind towers, we can modulate the arrangement of openings, we can plant more number of trees, and so on. Following these design strategies, we designed a church in Chandigarh, which is called Baptist Church. This church, you can see from the picture, the building got light color, white color primarily on the external facade, and even the top roof, vaulted roof, is painted white. This helps in reflecting the incident sun rays, and you can see small openings, deeply recessed openings. But these openings are well calculated and there's enough light inside. No artificial lighting is required. And when we submitted this building to Government of India, they rated it as one of the best 41 energy efficient buildings, and it was chosen by Terry. And it was published in a book produced by Government of India. You can see we introduced a cavity wall all around. In this plan, this is the cross section, and you can see the windows are deeply recessed or very narrow and small windows. Minimum use of glass, light colors. You can see the interiors. There's ample light during the day, but windows are minimal because they are properly calculated. Next building we did in Punjab, Mohali which is again a composite region. This was a Bal Bhavan, children's home. Here what we have done is, because western direction is very dangerous climatically. So because the western sun emits a lot of heat which goes into the building. What we have done is we clubbed all the toilets and we put all the toilets and mass on the front side, which is the western direction. So the toilet blocks absorb the heat and the dormitories remain cooler. Apart from that, you can see the deeply recessed or the projected projections of the balconies or the roof. They are protecting the windows in these photographs. There are windows are limited. Windows are put where the windows are actually needed, and they are properly protected. Existing trees are properly saved on the site. And next building in this category is a school, public school. A competition was held to design this school, and we have won this project because the design brief was site was having large number of trees, and this school belongs to the former Chief Minister of Punjab, Captain Amrinder Singh's family, and Captain Amrinder Singh's mother, who she was referred to as Rajmata here. Rajmata was the jury chairperson, and she gave a brief to all architects who were participating. She told us that we want a building which will not cut a single tree from the site. So we designed this junior school building in a manner so that not even a single tree is cut. While other architects gave a very flowery design because it's a junior school, widely spread and cutting. Somebody says I cut 10 trees, somebody says I cut 5 trees. But in our case, there's hardly any tree which was cut. So that was the reason why we got this project. And you can notice in this facade of the school, again, we have protected all the windows with the proper projections and the louvers. Why we opted for this design vocabulary? Because the existing school is designed by a very, very famous architect, J.K. Chaudhary. And this was an extension block. And we have to match the architecture of this school with the architecture of the J.K. Chaudhary's school. Who is J.K. Chaudhary? Who designed Punjab University's some buildings in Punjab University, and he designed IIT Delhi also. He was a very, very famous architect of India at that time, in 50s. You can see this is a new building, but all the existing trees are kept intact. And in order to make it playful, we have kept a 7-meter wide corridor in the middle. In this corridor, you can see in the plan there are cutouts on the either side. You see in the cross section, the wind comes from the windows and it enters the central circulation spine, and when the wind gets heated up, then the air can escape from the top vents. This is how it works. There's a corridor in the middle. There are cutouts on the either side. You can see a lot of light and lot of ventilation in the corridor, and it becomes very playful. And these cutouts also insulate the classrooms from the corridor noise, because young children, when they move in the corridor, they make a lot of gossip and noise. So the other classrooms are not disturbed when one class goes off. This is how we protected the windows in this school. And this is the Church of God we designed in Chandigarh. Again, this is a western facade, and we opted not to put any window on the western facade. There's an ample light in this church, but we have kept the windows, in other directions, or we have taken skylights, or some other measures were taken to bring natural light inside. But the western facade is kept totally dark. The plan form. Then we designed this Christian school at Patiala. Here, this blue color building was existing building, double story, but which cannot be extended vertically. The site of the school was very tight, limited site, and the school got upgraded, and we needed to design a building to cope up with the revised requirements of a high school. Earlier it was a primary school. So we added a T-shaped block, and this T-shaped block was added in such a manner, we utilized the existing corridor, singly loaded corridor, and we put our block parallel to it, and the new block is connected with the bridges with the existing corridor. And again, very simple kind of architecture, but this is what India is needing to control our harsh climatic conditions. You can see, we created a sort of a wind tunnel in the between. On the right side, we have a double-story existing block. On the left side, we have a triple-story block, and both the blocks are kept about 5-6 feet apart, and that gap in between both the buildings is working as a wind shaft. How we have covered the wind shaft from the top so that no rain can enter, yet light and ventilation remains intact. This is how you can see the bridges are connecting with the existing corridor on the existing roof, and on the right side is the new block. Then we designed a youth hostel in Patiala. This is the plan, swastik shaped plan, and you can see again, we have introduced rainwater spouts. We have kept all the windows very deep, about 2-meter deep balconies. And balconies are staggered to ensure privacy. And there's hardly any windows except toilets or stores which are put on the facade. All the windows and glazing and doors are deeply recessed. These are staggered balconies are ensuring privacy. You can see the rainwater spouts. You can see deeply recessed glazing and the doors. Then we designed a mental hospital. It's a small hospital, mental hospital in Barnala town of Punjab. This is the one. Again, you can see how we protected the windows from top, bottom, side, and because again this falls in a composite climate, and this is the only way to protect the buildings from the harsh climate. There's a small cutout in the middle which facilitates the ventilation. This is how we protected the windows. Another facade detail. This is the area for patients, very nicely designed by a artist. Murals are made on the wall. And then we designed a Red Cross building in Chandigarh. This is the building. You can again notice the same parameters. All windows are protected, all windows are small, and the building is facing the longer facade is facing north and south. These are the other views of the same building. Then we designed a Christian school, Baptist school in Chandigarh. Again, you can notice we put all the toilet blocks on the western side. Then we designed two courtyards in the middle, and some small, two big courtyards in the middle, and some small courtyards also. And on the external facade, you can see we have protected all the windows with a combination of horizontal and vertical louvers. This is the model. You can see courtyards, how the courtyards are placed and cutouts are placed. Plan form. Windows are properly protected. Courtyards, smaller courtyards are covered from the top so that rain cannot enter. Front facade, main entrance. Then we designed a ideas competition for HUDCO, and we got first prize in a competition organized by HUDCO. And this was the prize-winning model, prize-winning sketch. You can see in this sketch, we have provided earth berms, we have provided planters in front of the windows. You can see perforated parapets, and there's a staircase block in the middle which is having vents at the top. All these windows are properly protected, and upper floor residents are getting terrace. There's no rocket science in this. These are very, very simple things which we can learn from the history, as I said earlier. But gradually we have forgotten this, and we have switched over to the glass buildings. And this is the master plan of this housing project. And architect Anant Raje was the jury chief when we were declared the first prize winner in this project. You can see the courtyard planning, and these are the plan forms. You can see we have introduced a thick slab on the top, as was done in the Sangat complex of architect Balakrishna Doshi. Then we introduced solar lights, solar street lights, solar SV panels on the rooftop, and this is the cross section indicating the movement of air, movement of wind in the building plan. And next is a church, Lady Fatima Church, we designed in Patiala. Again, the same fundamentals, same design strategies were adopted. You can see the plan. All windows are protected with a circular wall, and this gives a cave kind of environment in the prayer hall, because nobody can see outside, nobody can peep outside. And these circular windows are protecting, these circular walls are protecting the windows, and the result is the building remains cool. And there are skylights in the cross section. You can see these are the skylights, and these skylights bring morning sun. This was I was mentioning. These walls are protecting the windows inside. You can see windows are behind these circular walls. Skylight. Then we got a chance to participate in a competition organized by Ministry of Agriculture, and this was a big convention center to be built in Delhi, and we got a first prize in this. In this convention center, the design brief was that we have to design a building which is energy efficient. The result is we designed this project. The entire roof is slanted towards southwestern side, and the roof is made of solar panels. Apart from that, we ensured that no tree is cut. We used perforated pavers. We introduced rainwater harvesting. We introduced we retained the existing trees in this project. We also introduced plants which consume less water. So these kind of features were introduced, and all the details were submitted to the ministry, and the result is that we got a first prize in this too. Then in the recent past, we designed a residential complex for officers of Reserve Bank of India at Jammu, and we submitted our proposal. And in this, there are different categories of houses. We have given the calculations how we can minimize the wastage of water, how we can segregate solid waste, and how we can harness solar energy, how we can play with the orientation and all those features. We have submitted, and as a result, we got a third prize in this All India competition. These are some pictures, sketches and visuals of the same project. Then we got a chance to design a university campus in Punjab near Ludhiana. The front side was northern side, and we faced a lot of opposition from our client. He wanted the buildings to be placed parallel to the road, but we insisted that we should orient the buildings to north-south. So anyway, we prevailed upon him, and we designed all the buildings, academic buildings mainly, which are facing north-south, because north-south is the best orientation in our kind of a climate. And you can see these are the academic blocks. All these classrooms and at ADAM areas, libraries, computer centers, they are all these openings are directly facing the north or the south side. This is the model. It's a huge project costing more than 300 crores in phase 1. Then we designed hostel blocks for postgraduate students in NIT Kurukshetra in Haryana state. Here also, we introduced similar features. We introduced courtyard planning. We introduced thick walls. We also protected all our glazings with balconies. Balconies are specially introduced so that students can use this as a outdoor area for drying their clothes or sitting outside whenever there's electricity failure and so on. And it's a huge project having 12 blocks, and nearly 1,000 students are staying in this complex, the postgraduate students of engineering. This is the plan. There's a huge dining block in the middle. You can see the courtyards, and all the buildings are connected with the central spine, which is connecting the hostel blocks at all levels. You can see courtyard, the deeply recessed glazings, balconies. Then a very, very small project in a remote village in Punjab. It's a library. This is the one. You can see in this library, we have given smaller openings, and openings are kept at a certain height because we wanted that book racks of the library should be placed along the external walls, because book rack itself, will be acting as an insulation material. So that idea worked, and this building is one of the green, known as Green Library in Punjab. And on the terrace, we got a system designed, of a, which you can see on the terrace. There's a cooler kind of a equipment. It sucks the hot air, it cools, and the cooled air is thrown down into the interior through ducts. You can see the ducts. Building is having cavity walls on the eastern and western side. You can see in this plan, and openings are only and only on north and south side. Openings are kept above the book rack height, and racks, you can see in this plan, are placed along the outer wall. Now these are the details, and the result is that we never needed any fans, we never needed any air conditioners to run this library, and building works very beautifully. So with this, we close on one part of my composite climate region, and now coming to the next one. That's the hot and dry region. How to design buildings in hot and dry region, which is Rajasthan and parts of Gujarat. We got a chance to design one housing project here. So what we did was we designed this project with the motto that we have to resist heat gain and we have to promote heat loss. How we can do this? Because basically orientation plays a major role. I will explain the project itself. You can see this is the housing township of having nearly 900 houses there. It is meant for Indian military. In this project, you can see 99% of the building blocks are facing north and south. Because in Rajasthan, when we design building, this is the best orientation. The longer side is kept on north and south. And I gave 16 presentations to Indian Army to convince them that this is the only way to design this township. But they were not agreeing originally. But finally, we convinced them. I have to go to Delhi 16 times to convince the army generals. You can see this. We use light colors again. We protected our windows properly. Deep, balconies are there for sitting outside, and self-shading facades are there. You can see self-shading facades. And we retained all the existing trees, whatever little trees were there in the desert. And that was one illustration of how we should design buildings in a hot climate like Rajasthan. Next is a climatic zone called warm and humid zone. We got a chance to design certain youth hostels in West Bengal, Odisha, and Assam, which are falling in this belt, warm and humid. Here the design mantra is we have to resist heat gain, promote heat loss, and the basic intention of designing, basic mantra of designing buildings in this region would be, as we, most of the architects we know, that we need to promote ventilation in this region. And this is the youth hostel in Bardhaman in West Bengal. You can see where number 4 is written is a purple color. It's a dormitory. It was a narrow site. We designed this, the plan form, and in this dormitory, we are getting about 6 openings in one dormitory in different directions, because it's a very remote area on the outskirts of Burdwan town, and electricity failure is very common, and how the youth will be able to stay in such a situation. So what we did was we opted to have plan where we put a lot of small windows, and the moment you open the windows, you get a lot of ventilation, and building remains cool, and we get a lot of rainfall in that area. So there was a need to select a color scheme to suit that climatic conditions. There was a need to protect the windows from all sides, because there's a huge rainfall experienced in that belt. So this is that's why we designed this kind of a facade. Because rainfall, we opted to have rainwater spouts, because rain pipes get choked in such public buildings, and then the roofs start leaking. And we introduced this kind of a concrete jali to facilitate ventilation in that area. Then we designed a youth hostel in Joshipur in Odisha. This is the plan form. You can see, it's an octagonal module which is clubbed together like a beehive, and one module is two modules are left empty because they become courtyard. And this is the building: light color, rainwater spouts, small openings, lot of ventilation, and this is the way to design buildings in such a climatic zone. And next is a moderate zone. When we design buildings in a moderate region, we have to resist heat gain, we have to promote heat loss, which is almost similar to the other categories, but here the climate is comparatively less harsh. So architects can take little liberty to design buildings, with better flexibility. And we never got a chance to design any building in this region, so we are taking some examples from other architects. So this is a very famous house and published in many journals. It's built in Bangalore. Vijay Darnapati is the architect, and in this project you can see there are earth berms. You can see the skylights, you can see cavity walls, earth berming. All these features were there. And a Bombay's famous architect Rumi Shroff, he designed the Bajaj Auto's corporate office. This one. You can see earth berms, you can see small openings, vertical windows, staggered windows in the plan, and white color exterior of the building. And this is how he brought natural light in the atrium, because this is the requirement of Indian architecture. And next is the category which is called cold and cloudy region, which is Jammu Kashmir and parts of Himachal. Here the design strategies are totally different. We have to resist heat loss, and we have to promote heat gain. We have to promote heat gain. It is highlighted because in a cold climate we need more heat. And I'm borrowing this example from famous architect Ashok B. Lal's very small project in Shimla. It's a cooperative bank. you can see this picture. There's a glass screen on the front side, and behind this is a solid wall. It looks very strange, but how it works, I will show you in cross section. You see, in this cross section, you can see there is a glass screen. You know, when the sunlight falls on this glass screen on the front side, which is on my left side, uh, it heats the air in between solid wall and the glass wall, and the heated air naturally goes up, and the heated air is then taken to the interiors of this bank through the ducts. So during sunlight, during sunny days, the building gets comparatively heated up with the natural sunlight because it heats the air, and the heated air is taken to the interiors. And the result is there's a much less expenditure on heating this particular building during the winters. And we got a opportunity to design a composite regional center in Srinagar in Jammu, Kashmir. This is the project we designed because we have a lot of snowfall in that belt, and people complain that snow, when it falls, it gets accumulated on the rooftop. Either it is required to be cleaned mechanically, or it is required to be cleaned manually. So then I studied how we can solve it. Some mason in Kashmir told me that sir, if you keep a particular angle of this slope, then snow falls automatically down. So I said, okay, let me do it. We did it, and there was never a requirement to clean the snow. It falls automatically on its own. And apart from that, you can see we have taken other measures to control the climatic conditions there. There's an atrium in the middle. You can see the Google image. It's a swastika shaped building. This particular shape is chosen because it's a sacred symbol of our religion. Then you can see the perspective view. You can see the cross section of this. We have taken the atrium is covered with a twin wall sheet, the transparent sheet, polycarbonate sheet, which brings in a lot of heat and light, but not the it shields the building from the cold climate. Then next section of my presentation is we normally call that we need to design energy efficient buildings. What is energy efficient building? We all know that buildings consume energy in heating, cooling, lighting, water heating, and running of the appliances. Energy efficient building is one where with our inputs we are able to reduce the consumption of energy. So that is a very simpler definition. And these are some of the tips. In this sketch indicates we can introduce earth bounds. We can avoid paving the external areas because when we pave a lot of areas outside our buildings, then it reflects a lot of heat. We can create atrium in the middle. We can shade our windows. We can put trees on the western side, and we can put some escape route from where the wind the hot air can escape from the atrium. And we can keep some margin to put solar panels on the rooftop. So these are some of the tips for designing the climate responsive buildings. We can have cavity walls, we can have cavity roofs, and we can use reflective materials on the roof terrace. like this China mosaic in this particular slide. This China mosaic is used in Sangat complex of Balakrishna Doshi also in Ahmedabad with the same intentions. When we choose the building plan shape, we should opt for the compact buildings. The compact buildings consume less energy. If we increase the surface area of the buildings, they consume more energy. Then this is the last segment. There are various technologies and concepts available around the world from which we can learn something. Today we have a technology which can transport sunlight from the rooftop without having any batteries. You put the solar panels on the rooftop and don't use any batteries, and that solar panels can directly bring light into the third deep basement with the help of fiber optic cable. This technology is available. And I have seen that there's no need to cut the trees now. And this kind of mechanism is available to transplant the existing trees at some other location. Even I have seen in Surat Municipal Corporation, the grown-up trees are sold to the builders at the price of something like 2 lakh rupees. Because builders are having township outside the city where it takes years to plant and grow the trees. So I have seen that they are buying some trees from the local municipal corporation, which are planning to cut those trees, and those trees are taken away, uprooted from there, and they were replanted outside on the city's boundaries where new townships are coming up. Then where we have less area and we need more light, this is a concept called solar tree. It's designed by a very famous designer called Ross Love. He designed this concept of solar tree. He said we can have more light where we have less area. We can plant this kind of a solar tree. And we in Chandigarh have designed this solar tree in Mohali. So this is already working there. And lot of research is going on to design green elevators. Engineers are working that, when with the movement of the trolley, we can generate electricity, and with that electricity, the elevators can be run. In Varanasi Municipal Corporation, they are doing something great. We all talk about the plastic waste. What to do with plastic waste in our cities? So Varanasi Municipal Corporation has done, they use this waste in the road construction, and they have experimented it, and it is found to be very successful. They used 8% of plastic waste in the bitumen, and they are claiming that roads become waterproof, and they have a better life and a long life. At the same time, they are utilizing the plastic waste also. Another new concept is urban agriculture, or we call it vertical farms. Professor Dixon from America came up with this unique concept. He says with the growing urbanization, we are losing on the agricultural land. So what is the way forward? He says we can think of having agriculture on our buildings. How we can do it, he has demonstrated. So he has his own logics and reasons to give that what are the advantages of urban farms. He says you can produce more in a less area. He says weather cannot affect these crops if they are grown. If the crops are grown in a controlled environment, like within the building. And as a demonstrative project, this project in Tokyo called Pasona Urban Farm, designed by a New York-based firm Kono Designs. They have designed this urban farm, nearly 10 years back. And it's a 9-story tower. This whole facade and interior terrace, they are growing vegetables and they are growing creepers. And they claim that all the employees of this building are using vegetables and fruits which are grown within this building. This is the basement of that building. You see how the crops are grown in this project. Then another technology. There are energy generating pavements now. These are the, these slabs are made of 100% recycled rubber, and they are used on the pavements, and they can produce a certain amount of electricity with the footfall. Then nano glass, new technologies are advocating nano glass. They say it's water repelling, it's a dirt deflecting, and so on. Then, in Chandigarh particularly, we have experienced that all the buildings designed by Corbusier in exposed concrete got blackened with the weathering effect. So this Jubilee Church is made with a new kind of a technology, with a new concrete which never gets blackened. This is a Bahrain World Trade Center in Bahrain. I have personally seen this building. It's designed by a very famous South African architect, Sean Killa. He was invited to Bombay for delivering a talk also. And 2 towers, nearly 800 feet tall, are put at an angle. You can see in this picture, they are put at an angle to receive the wind. And then, these towers are put in a manner so that they give a funnel effect to the wind. And in the middle, you can see in this picture, both the buildings are connected with 3 bridges, and 3 bridges are having turbines, wind turbines. With the focused, thrust of the wind, these wind turbines move and they generate electricity to the tune of meeting the energy requirements of this particular project. The architect claims that we are generating electricity worth 15% of the total energy requirement. I think it's a wonderful project and wonderful idea also. And this diameter of this wind turbine is, you cannot imagine, it's something like 90 feet, a huge wind turbine. And these bridges are used to install them, to repair them, to maintain them. You can see the close-up of the wind turbines. Then, like we discussed, solar trees. Now there is a new concept which is catching up. It's called wind trees. There's a belief that we can have wind turbines where we get a particular speed of the air, particular speed of the wind, because otherwise wind turbine never works. But some engineers, some scientists have come up with a new concept called wind trees, and they are claiming that this kind of a wind tree, if installed, as you can see in this picture, they can produce electricity from a very less wind speed of even 7 kilometers per hour or so. And you can see the close-up of the leaf design in particular. They catch the slow moving wind and then they convert that wind into a energy. And we are using this concept in one of our projects now. Another theoretical proposition is some architects and some engineers are working on a model of solar towers. What is solar tower? It is claimed that when we design multi-story buildings in very downtown areas of New York and Manhattan and so on, the roof terrace area is so less, and the roof terrace area is occupied by water tanks and lift towers and many other equipments. So there's hardly any space left on the roof where solar panels can be placed. So what is the option? They say you can design these kind of solar towers. You can see in this photo close up on the left side, there's a round shaped disc kind of a structure. This disc is a sun tracking solar panel. It moves according to the sun direction with the sensors, and the team which is working on this concept is claiming that if this system succeeds, it can this sun tracking solar PV panels in a disc shape can generate more than 30 to 40% of the more energy than any conventional building. It's a very unique concept. And earlier we used to believe that when we have a vaulted roof or an angular roof, we cannot have solar panels on it. But now technologies and materials are available that even on a circular vaulted roof or on an angular roof, we can have solar panels. So it is very much possible now. When we don't get enough area on the roof terrace to put the solar panels, what we do? We can clad the buildings with solar panels. We can design in this particular building, you can see the sun shading devices are made of solar panels. It's in Switzerland, not in Germany. It's wrongly typed by me. Then in this building in Hong Kong, the glazing itself is made of solar panels. In this building in Finland, you can see the railings are designed, all the railings of this building are designed and made of solar panels. These are all demonstrative projects which are being shown to you that how innovatively we can use solar panels. And this is a project designed by Skidmore, Owings and Merrill in Paris, which is called net positive building energy. They claim that this building will produce more energy than it will consume. How it is possible? Because the entire building is designed in such a manner to the roof is made of solar panels, the front facade, the rear facade, the connecting corridors, everything is harnessing the solar energy in a proper way. So the end result is that building will produce more energy than it actually consumes. And I think this is the only way forward. And in order to utilize the waste Coca-Cola bottles of the larger size, Nigerian rural people have come up with the idea that these kind of houses which are made of waste Coca-Cola bottles, how they have used it? They are making houses with putting Coca-Cola bottles one above the other. How it is possible? They fill this Coca-Cola bottle with their sand, put the lid on it, then they are put one behind the above, and they are tied together with a thin nylon rope, and no bricks are needed, and they are making such houses in Nigerian rural areas. The poor people can at least get a shelter. So these are some of the ideas where various success stories are being are shown to you, how we can use waste materials, how we can harness energy, and what is the way to design buildings. And the conclusion of my talk is that India is a huge subcontinent, and it is divided into 5 climatic zones, and each zone has its own guidelines, its own parameters to design the buildings. We cannot design the same building in Bangalore and same building in Bhopal and same building in Chandigarh. Each location, each orientation matters. And if we want to save Mother Earth, if we want to save the environment, if we want to go by what our religion has taught us, we should design the buildings to save the environment and the Mother Earth. Thank you so much.
Thanks a lot, sir. Now the session is open for question, answer, and any query or discussion. Please feel free to ask questions.
Good.
Anyone, please?
I have explained my presentation in such a simple manner. I think all would have understood everything.
Actually, sir, it was very, very much clear, and all the aspects you have covered, designing simple, using simple elements of building, and how they can be converted into a sunshade device, like you have designed windows in different kinds, and roofing or chhajja projections. So, and how you did different projects in different regions, how you designed different buildings in different climatic conditions, and all other projects also you have displayed, which designed by other architects, how they have considered all these design elements and aspects to make the building more energy efficient. It was very nice presentation of you. I think Shikha ma'am want to
Yeah.
discuss or ask something.
Yeah, so your presentation was very interesting, and you have covered so many aspects of climatic conditions, so we will get inspiration to do something like you.
Thank you, ma'am. Thank you so much.
चारू मैडम,
या हाँ जी सर,
मैं एक
बिल्कुल
प्रश्न
सर,
पूछना सर से प्रश्न पूछना चाहता हूँ।
बिल्कुल सर।
सर हिंदी में चलेगा सर?
More than, sir, more than.
कि
दौड़ेगा सर वो।
पति पत्नी और 2 बच्चे, इन 4 लोगों के लिए एक आदर्श प्लाट साइज क्या हो जिसमें ये अधिकतम स्वास्थ्य संबंधी सारी पूर्ति हो जाए? मिनिमम प्लाट साइज क्या हो जिसमें ऐसा मकान बना सकें जिसमें ये हवा, धूप, एनर्जी सेविंग सारी चीजों का उपयोग हो जाए? एक आदर्श प्लाट साइज
सर 100 स्क्वायर यार्ड में बन जाएगा।
थैंक यू।
जी, और भी कोई? आपने सर काफी सारे जो टेक्नोलॉजिकल एडवांसमेंट हुए हैं उनको भी कवर किया, तो उसमें से तो काफी कुछ मतलब हमें भी जानकारी नहीं थी। यहाँ पर तो काफी सारे लोग अभी पार्टिसिपेंट्स में ऐसे हैं जो कि फ्रॉम नॉन आर्किटेक्चरल और नॉन सिविल बैकग्राउंड, तो दे मस्ट हैव गेट बेनिफिटेड विद दीज थिंग्स, क्योंकि सिर्फ डिजाइन करना ही ऑब्जेक्टिव नहीं होता है। हमेशा कई बार हमारी अवेयरनेस बहुत काम आती है कि हम अपना घर या अपने आसपास जो हो रहा है उसमें भी हम कैसे इनका यूज कर सकते हैं।
हाँ बिल्कुल मैम, दिस इज फॉर एवरीबॉडी, आर्किटेक्चर इज मेंट फॉर एवरीबॉडी बिकॉज एवरीबॉडी नीड्स शेल्टर, एवरीबॉडी नीड्स होम।
तो अगर अवेयरनेस होगी तो हम अपने घर की डिजाइन में भी बदले, हम आर्किटेक्ट ना हो या इंजीनियर ना हो,
हाँ बिल्कुल मैम, बिल्कुल।
एटलीस्ट हम वो उन चीजों को ध्यान में रख करके किसी को भी सजेस्ट कर सकते हैं कि हमारा ऐसा बना के दीजिए।
बिल्कुल मैम, बिल्कुल सही।
That is what the motive behind this whole program. That is why the program is free for different background people. And
It's a wonderful initiative.
thanks a lot, sir,
Okay,
having
ma'am.
you, and you have given so much of time for us, and thanks a lot, sir. We
Thank you,
will
ma'am.
need your support again in future, and we will again come to you back for this.
Thank you, ma'am. Thank you so much.
Thanks a lot, sir. So thank you, everyone. And with this, we are going to end this session. You have to fill your attendance again, and tomorrow we will have first lecture of Surinder Baga sir itself at 10:30 p.m. And then we will have two more lectures, and I will let you confirm about the speakers, because as I mentioned earlier, both of the speakers of the second and third session are affected with COVID, and I will let you know how the second and third session will go. Okay. Thanks to all, and very good evening to everyone.